Okay, so let's start with the PostgreSQL memory and parameter management. Okay, so parameters are actually they affect the behavior of a database system, just like Oracle parameters, like any database parameters. There are some parameters which define the behavior of your database system. Okay, so you can change your parameters at different level. Okay, in Postgres there are different level where you can change your parameter. One is the cluster level. Okay, that is the wholesome, right? That is changed by alter system. Okay, that is changed by
Mm-hmm.
alter system at cluster level. Then you can change the parameter at session level as well. You can change the parameter at user level. You can change the parameter database level as well. Okay, so there can be parameters that are at different database level. There can be parameters at user level, and there can be parameters at session level as well. Okay, there can be parameters at either of these levels, at any of the level, session level, user level, database level. And an order of precedence is session, user, database, cluster. Okay, that means is if somebody is setting the parameter session level, that is effective, right? If somebody is setting like memory parameter, okay, if at a cluster level the memory parameter is 5 MB, at a session level it is 4 MB, user level maybe 5 MB, database might be 3 MB. So at session level will be effective, right? So whatever is
Mm-hmm.
there at the lowest level, that would be affected at particular level. Okay, if particular user is logging, so for that user level will take care, will override the other parameter. If nothing is set at this levels, then cluster level parameter will work. Okay, just like with
And this,
anything. Hmm?
mm-hmm. Okay, but this comes into effect when, like session, user, database, cluster.
See, all the parameters are there in the file in PostgreSQL.conf. You have seen that, right?
Yes, yes.
PostgreSQL.conf, there are all the parameters. Okay. So now you can change these parameters with at different levels. So now means is you are logging to Postgres database. Okay. So at a cluster level, memory parameter is 6 MB, but at database level it is 5 MB. So Postgres database 5 MB will work, memory parameter. For other
Mm-hmm.
databases, might be 6 MB will work. Okay, whatever is there is PostgreSQL. So by default, everything is set at the cluster level. Okay, by default, nothing is set at session level, user level. By default, everything is at the cluster level, just like Oracle database also. By default, is everything. Sometimes you
Mm-hmm.
change the parameters at database level or session level, right? We use alter session command. Or if you do alter system command, parameters change at the cluster level. Okay, same like alter system command. For database level, we have to see alter database at database level, alter user
Oh,
for
okay,
user
okay,
level,
okay,
set command.
okay.
There is no alter session. There is only set command. We do set command. The parameter is set at the session level. So we can
Mm-hmm.
see all the parameters with the command of name, setting, context from PG settings, select staff from PG file settings. So PG file setting is a table where you can see all the parameters. Okay, where you can see all the parameter, or we can do a show parameter as well, show and parameter name. Now there is one more thing, context. Context is very important. Okay, context means is something how the parameter can be changed. Just like in Oracle, if I say there are static and dynamic parameters, some parameter can be changed at the runtime, some parameter are static, only restart is required. Similarly, in Postgres as well, there are some parameter which have a context. Okay, context means is like how this parameter can be changed. Okay, how this parameter can be changed, and like how the effective the parameter is. Okay, so context first is the internal. Okay, internal parameter is a parameter which cannot be changed. Actually, once a database is created, this parameter cannot be changed, just like a block size. Okay, a database block size, block size cannot be changed. Once the database is created, once the cluster is created, you cannot change this parameter. This is an internal parameter, this cannot be changed. I can only change it before creating the cluster. Okay, before creating the cluster, I can just change this parameter. After the cluster is created, I cannot change this parameter anyhow.
Mm-hmm.
Fine. Second is the postmaster. Postmaster is the parameter which requires a server restart. If I change this parameter, I need a server restart. Okay, okay, whenever this kind of a static kind of parameter where it requires a server restart, if I change this parameter. Then is the SIUP. SIUP is kind of parameter which will be effective at kind of reload. Okay, in case of reload. Okay, in case of reload only, this parameter can be changed. Okay, in case of reload, this parameter can be changed. Super user is a parameter can be changed during runtime or using reload, but can only be changed by the super user. Okay, this parameter can only be changed by the super user. Super user is the Postgres user by default, but definitely you can grant super user to anybody. So this parameter can only be changed by a super user. It cannot be changed by other. Okay, this can be a part of postmaster, or this can be a SIUP parameter. Okay, SIUP means reload. I think I've told you how to reload. Okay, there's a command pgctl reload. You need not to stop and start. It does not stop or start or restart anything. So it is it kind of non-outage kind of service. Okay, it will only block the connection, might be for a second or so. Otherwise, it will not start and stop your database. So you are safe from the restart. Then is the user level. User level is the parameter which can be changed at a session level, can be changed at local level, or at a user level. Any user is allowed to change this parameter. So any user is allowed to change this parameter. No restart is required, nothing is required. This is a user level parameter. So the lowest parameter, like this is most simpler to change. No restart required, no reload required, no super user access required. So there are kind of 5 kind of parameters you can. There are kind of 5 kind of parameters which are there. Okay. Now, okay. Now let us have a look on all those parameters. Okay. So these are the parameters in PostgreSQL.conf. Okay, you can see all these parameters: listen, address, port. So whatever is with the hash, that means it is by default. Okay, that is by default. Other than that, I have just changed this parameters. So max connection, super user, all these parameters are, all these are part of the parameters. Shared buffers, this 128 MB. Okay, all these are the parameters of the database. You can see all these parameters. Now if I log into the database, now there are multiple ways to change this parameter. Simpler way is, okay, I go ahead, I log into this file. Okay, and then I go to any parameter, maybe shared buffers. Okay, I change this parameter 132 MB. I change this and say PS equal minus P, pgctl minus D. What is the data directory? pgctl minus D where lib pgsql 12 data restart. Okay, I restart this. Okay, new parameter will be effective. Okay, that is simple. Okay, next way is, now how to see this parameter. I can say show shared buffers. Now see 132 MB is coming up, right? There is one table known as pg underscore settings. You can do name, setting, and context. That are the important column. So you can see all this. This is the name. This is current value of, what is the setting? This is postmaster parameter. Postmaster means that it requires a restart. Auto vacuum. Auto vacuum is a SIUP parameter. So let us change some parameter like auto vacuum. Auto vacuum is on, right? So today alter system set auto vacuum. Auto vacuum is equal to off. Okay. See, it is still on. Why it is on?
Because we didn't do the reload.
Reload, yes. So we do pgctl instead of restart, we just do a reload. That's it. Auto vacuum. off. Now it is off. Correct, it is off. So in this way you can change this alt one. Now if I do any postmaster parameter, okay, I don't know what is bonjour parameter is. Now if you go ahead and change any postmaster parameter, for the postmaster parameter, I need not to do a reload. I have to restart, just like archive mode. If I say archive mode is equal to on, I have to do a restart. Auto vacuum max workers, this is also a postmaster. So if I say alter system set, you understand the point, right?
Yeah.
Now if I do auto is equal to 4, it will not, this parameter will not change until unless I restart, until unless I restart my database. Until unless I restart my database. It is still showing 3 because I've not restarted. Now, one thing more I tell you about this parameter of this postmaster parameters. This postmaster because see all the parameters in the this is not a binary file. If you have noticed, this is not a binary file. This is a text file, right? This is a text file, normal text file. So as it is a text file, you cannot go ahead and make changes from the system. It is not possible to make the changes to the text file, correct?
Yeah.
Right? If I do alter system, the changes will not be made. So what Postgres has done is Postgres has created one more file, PostgreSQL.conf, PostgreSQL.auto.conf. Okay. So whatever parameter you change will go to the auto.conf. You have seen this? We have make
Okay.
off and all. So these parameter will go to PostgreSQL.auto.conf. So what will happen whenever you restart your system? First PostgreSQL.conf opens. Okay. After that PostgreSQL.auto.conf get opened. Okay. So whatever
Mhm.
parameters are there in auto.conf, that gets override the parameters in PostgreSQL.conf parameters. That is how it
Mhm.
works. Okay. This is how it works. Okay, so whatever parameter changes, it will happen in this way. Okay.
Okay.
So now if you want to change some parameter at a database level, so you can just say alter database, maybe the name of the database Postgres, um, set set work mem is equal to 5. Just a minute, maybe it is 5 MB or
Mm.
show work mem. Okay, let me try a single quotes for 1 minute. Yeah, okay. Okay, so now this, if I do this, then changes are made at the database level. Okay, at the cluster level, parameter is 4 MB, but at a database level, the parameter will become 5 MB because I'm changing the parameter at database level, Postgres. Okay, now I can change the parameter at the session level. That means the only the current session, the parameter is changed. Now such parameter are the user parameter. If you remember, some parameter which can be changed by anybody are the user parameters. Okay, this is kind of a risky also, but this is how it is designed. Okay, setting where context is equal to user. Oh, I'm sorry, I did not do the from. Okay, so these are all the user parameters. These are the user parameter. Important one is the work memory. Actually, work memory
Mhm.
is, I think I told you, work memory is the memory for each session, a kind of a PGA for each session. Okay, so So work memory you can change if you assuming your session will take up, your session is taking more memory or needs more memory, you can change the work memory. By default it is 4 MB, but general cases 4 MB is very small. But you should not increase it at the cluster level, because there would be a lot of sessions running and which might not be needing that much of memory. For a good session where you have to do some query, some kind of task you have to do, you can increase the work memory. You can do with the set work memory command, and you can increase the work memory, and then you can execute your all your SQL statement, whatever it is. Okay, so this is the way I can change the parameter at DB level, at a session level, or at a system level, and a cluster level. These are all the different ways. Okay, fine. So so what we have discussed it at session level, we can change it with this way. At just like
Mm-hmm.
at session level we can what is coming up. Okay, just wait. Okay. Oh yeah, where is this pen going on? Mm, So, oh yeah, I don't know where the pen is gone. Okay, leave it. Okay, so you can change the parameter at session level with set default table space is equal to T1. Then you can do a login and log out, the value would be changed. So whenever you change the parameter at the session level, it will remain effective till the time you don't log out. Once you log out, that parameter will go off. At a user
Okay.
level, you can change with this parameter with alter user. So with anytime you log in with this user Postgres, this parameter will be effective. Okay, so user level will override the parameter at database level. Okay, if you are at a database, maybe some DB1, but the user is Postgres, so Postgres will be the default parameter which will work out. Okay, so user just like default table space is also a kind of a parameter. Okay, so default table space is kind of a parameter. So default table space means any table that is being created will be created in this tables with this table space.
Okay.
Okay, so this is kind of also a parameter.
So this session level table space and all, only this thing super user can set, or both the user and super user both they can set it.
Which one?
Like for example, changing at the session level.
Session
So
level
this.
anybody can set.
Uh-huh.
Session level anybody can set.
Okay. And user level also only user can set it.
Yes, yes. Only the super user can set it. Whoever has get the privilege of altering the user will able to set it.
Mm-hmm.
And session level anybody can set it. So anybody can change its memory parameter or and can take up the session more memory on the session level.
Mm-hmm. Mm-hmm.
Okay, so at a database level, you have different parameters. Like you can change the name of your database as well with the alter database command. You can set the connection limit. Okay, how many connection can he connect to the database? At a cluster level, the parameter is 100. Okay, that is very small actually. Practically, it is very small. Generally, you have to generally you change it. Okay, generally you change it.
Mm-hmm.
Then you can change your table space as well at a database level. You can change different configuration parameter. You can reset all the parameters as well in one go. Just like you have changed a lot of parameters, now you're a bit confused and you want to go back to the what are the default settings are. Okay, that also you can do. That also you can do. You can change, you can just go ahead and reset. You can just say alter database, reset all. So all the parameters will get changed. Okay, you can change your work memory. Okay, or reset all will work at all levels, like database, user level, everywhere it will work. Okay, so these are different parameters. These are the different parameters. You can check. These are the different parameters, just like listen address. Now these are the important parameter we are talking about, because there are a lot of thousands of parameters. Okay, maybe we can not go through all the parameters. Just to have a quick idea, I have just taken out some important parameter which we generally use. Okay, listen address is very, very important, and moreover you have to change it anyways. Listen address is restricting every session to connect to the database. So listen address by default, listen address is kind of a security for your database as well, one kind of security. Listen address by default, only the local host, only this, just like the server where your database is, only that server can connect to your database. Okay, but in listen address you have to specify the IP address from where the connections will come. Okay, this kind of a security I've not seen in any other database. This kind of parameter in listen address, you have to mention that what all connection will be made to your cluster, from all which IP address the connection will come up. Okay, so whatever connection IP address you mention here, only from that connection will be accepted to the cluster. Otherwise connection will not be accepted from that IP address. To make it more simpler, if you don't have the list of IP address, or might be not getting feasible for you, you can put an asterisk sign as well. If you put an asterisk sign, then connection will be accepted from all the databases. Okay,
Mm-hmm.
the port number by default is 5432. You can change your port number. Right, first database definitely it's first cluster, you can create on 5432. Next cluster definitely you have to create on different port. Yeah, so you can change your port number anytime. Okay, so port number is one thing. Now maximum connection is also very like you have to change it. You have to change it, because 100 for kind of a production database, because all the settings generally are for development database kind of. Okay, but if you want to build a production database, 100 is, you understand, 100 is very less, right? There can be more than 100
Mm-hmm.
connection at one time. So 100 you have to change. Okay, it is not even 100, it is 97 actually. So 3 connections are reserved for super users. Okay, this is the next parameter, super user reserved connection. So 3 connections are reserved for the super users, and the rest is for 97 is for other users. Unix socket directory default is temp. The directory to be used for Unix socket connection to the server, that is the directory for all kind of networking kind of information, the temp kind of whatever work is going. So you want to build some different temp, you can build up different temp as well. Okay,
Mm-hmm.
okay, so let me clear this. Some important memory parameters. Okay, shared buffer, you can understand shared buffer, that is the main memory parameter for table, for caching of table. Okay, recommended to set this parameter to about 25% of the system memory. So what does the Postgres recommend is to have 25% of the system memory in the shared buffer. In the shared buffer you have 25% of the system memory. So if your it is 1 GB, you can put a 250 MB, but there is this is just a standard. Okay, you can put it 80% of your system memory as well. Okay, but actually you should think about in this way, there is no such limit to the database. Now shared buffer is different and work memory is different. Work memory will depend on the number of sessions. Okay, now next is work memory. So if I say work memory is 4 MB, now assume there are 4,000 or 1,000 connection, assume 1,000 connections at one time to the database, then automatically the size allocated to the work memory will become how much? 4 GB, right? 4,000 MB.
Mm-hmm.
So there is no limit on the work memory. It all depends on the session. Okay, if I compare with Oracle database, in Oracle database, there is a limit to the PGA. If I set 2 GB or 3 GB or 7 GB, there's a limit. 7 GB will not go outside of 7 GB. But here there is no limit. I think you have, like, we have to think about in this way. So we should not give much to the shared buffer. We give 25% of the system memory to the shared buffer, and we have to keep something for the work memory and something for the operating system level as well, because
Mm-hmm.
everything will depend on the number of connections. So now there's a limit. Now connection limit is also used in this Postgres, just to keep in the mind that work memory, there should be some limitation on the work memory kind of. Okay, so work memory is 4 MB by default, but recommended memory is 30 MB. Don't go ahead and do 30 MB at a cluster level. I would suggest moreover do at the database level. Give it at more mature level, kind of somebody, some users who are really mature users, you can give it more memory to those users, or some databases where the work is more, where the production database is kind of, you can give it to that as well.
Mm-hmm.
Okay, so this is kind of work memory. Then is the temporary buffers. uh Work memory is all kind of a task which is done by sorting and hashing kind of task. Sorting, hashing, all kind of such tasks is done by the work memory. Temporary buffers is the size which is taken by the temporary tables, that is the temporary buffers, and that is by the temporary. Now this is not always used whenever you create a temporary table, then only this memory will come up. Then is the maintenance work memory. Maintenance work memory is the memory that is used by your vacuuming, auto vacuuming, such sessions. This memory is taken. So by default it is 64 MB. Recommended value is 1 GB. Okay, if you are doing some vacuuming, because sometimes in some databases, in production databases, we keep auto vacuum as completely off. Okay, we keep auto
Mm-hmm.
vacuum is completely off just because it is running, keep on running on the background, keep on cleaning. So when performance is an issue, then we have to take care of performance level as well. We keep auto vacuum as off, and we just do vacuuming of the complete database during weekends. So whenever we're doing a vacuuming, then we can allocate 1 GB or 2 GB to maintenance work memory, so that vacuuming process takes up that memory and completes vacuuming as soon as possible.
Okay.
Okay, so these are the 4 memory parameter, not much complex like Oracle or other databases. There are only 4 memory parameters. One is shared buffer, that is at the cluster level, not at the database level, not at the user level. Work memory, that is at the session level. Okay, that is used for sorting scenarios, only for sorting, hashing scenarios. Temporary buffers only when a temporary table is created. Maintenance work memory whenever we're doing any vacuuming or re-indexing kind of work. Okay. Okay, so this is other parameter like auto vacuum work memory. This is especially for this maintenance work memory is for all vacuuming reindexes. This is only for auto vacuum. So auto vacuum is also equal to maintenance work memory. Is defaults to 1. By default it is equal. If you want to have more size to auto vacuum, you can increase it over here. Huge pages, effective cache size is the cache size limit on the disk. Okay, on the disk, if you want to set some limit, I think by default it is a huge amount, like almost in GB, 64 GB kind of. Okay, so it is a caching required on the disk. Okay, kind of a paging or such kind of there. So that is effective cache size. This is the size which is there on the disk. If you want to more, you can increase the size. I think it's already 64 or 32 GB kind of. Huge pages is a Linux huge page facility. Values can be on, off, and try. Default is try. I don't know about this. Anybody has a Linux experience will know about this huge pages. Okay, so huge pages facility is
Mm-hmm.
also there, right? This, I think this parameter we also work on the Oracle level as well. In Oracle databases also we check on this parameter, huge pages sometimes.
Okay.
Okay, so now there are temporary files that are created in the database. These all are temporary files are created in pgsql.temp. You can see this file from this you can check this temporary space from this parameter. Okay, so there are other parameter like checkpoint. I hope you understand what is the checkpoint is. Checkpoint is a trigger. Once this trigger is executed, then what happens is the database writes the data, whatever the data is there in shared buffer, that is pushed into disk. That is pushed into disk. That is the share. Um, that is the checkpoint, right? That is checkpoint. That is clear, right?
Mm-hmm.
Checkpoint timeout is something that after how much time this checkpoint will be executed. So default is 5 minutes. That means every 5 minutes this checkpoint will be executed. Okay, every 5 minutes this checkpoint will be executed. That is a checkpoint timeout. So every 5 minutes this checkpoint will be executed. Okay, so this is not defining any like how much buffer space is left or how much this or that. So it just depend on the timing. Okay, it is also only working on the timing. If once the time is 5 minutes is over, checkpoint will be executed. Okay, the data will be written. So now there is one more concern, that when checkpoint is executed, it will push all the data to the disk at one time. This will create a huge IO on the disk. Okay, this create a huge IO on the disk. So now to avoid this, that it should not write in one go all the data on the disk. It should write like it should take time to write to the disk. It should take time to write to the disk. It should not write in just one go to the disk. There is one more parameter which is known as checkpoint completion target. Okay, checkpoint completion target, what does it means is it depends is it sees how much time it will take to write to the disk. So default is zero point 0.5, yani 50% of the time of the checkpoint timeout. So 50% of the time, that means if the checkpoint timeout is 5 minutes, it will take 2.5 minutes to write the data to the disk. So that it should take some time to the write to the disk. It should not go ahead and push the data immediately and create burden of IO. It should go and write to the 2.5 minutes. You can also make it 90%. So 90% of the time it is writing to the disk, not putting any burden, slowly and steadily is writing to the disk. Also you can do that. You got this point? Any confusion in
Yeah.
this?
No, it's fine.
Okay, then there is an fsync. Fsync is something okay, it is fsync is flushing the data to the disk for crash safety. So it'll try to flush the data to the disk. The default is on to avoid any kind of a crash like situation. This is a flush is the fsync. Then is a background writer. All these are the background writer parameters. I think these generally we don't change. Okay, but if there is any such IO issues, we should know these parameters. So background writer delay 200 millisecond, that means sleep time after each write, it can be reduced for the tuning purposes. So it means is that how much time it will sleep in between writing. So 200 millisecond will write, one write it will do, and then sleep, one write will do sleep for 200 millisecond. Then there is background LRU max pages. Similarly, there is a parameter in Oracle as well, if you remember.
No.
LRU max pages is the number of pages
Yes,
it writes
yes,
it each time. So
there
by
is on
default
LRU, but
there's a parameter like it will write at each time. There's very similar parameter which is known as DB multi-block read count. Kind of one read, how many blocks it read at one time. Okay, now in the same way, how many pages it will write in one time. That is the BG writer LRU max pages. So at one time it will write maximum, it will write 100 pages, and then will sleep for some time, then will write. So just so that it can give space to other processes as well. Okay, because I hope you know that internally there is no concurrency. There is something, everything happens for few seconds, then it will sleep, then it happens for few seconds, then it will sleep, kind of. So this is some internal parameter which maybe if you go down deep down you can change it. So maximum is background writer delay, LRU max pages, number of pages to write. Then this is cleanup, it will clean up the number of pages what Postgres server request for. Okay, so this will number of pages it will clean up. Okay, now these are pretty important parameter which is there for the val writers. Okay, val parameter, then there are the archive parameters. Okay, I think today we'll do up to this. Okay, val and archive. So val parameters are the which will define the level of Postgres. uh, okay, maybe in next like in next lecture we'll complete this val parameters. Okay, bye for then.